Alright, now we're on week 6. Today we're going to be exploring the world of artificial intelligence and how machines learn, improve, and align with human expectations. Our focus will be on three key areas: neural networks, reinforcement learning, and AI alignment through human feedback. These concepts power AI applications ranging from self driving cars to recommendation systems and bot chats like ChatGPT. By the end of the presentation, you'll understand how AI learns and why reinforcement learning is important, and how human feedback helps make AI safer and more effective. So, let's go. Intro to neural networks. Neural networks are the foundation of modern AI. They work similarly to the human brain, recognizing patterns, making predictions, and improving over time. Unlike traditional programming, where every step is explicitly coded, networks learn from data. This ability allows AI to handle complex tasks like voice recognition, medical diagnosis, and language translations. Whether it's your phone unlocking using facial recognition or virtual assistant responding to your voice, neural networks are at the core of these advancements. Now, some key components of neural networks. A neural network consists of multiple layers, each playing a crucial role in processing information. The input layer receives raw data like an image or a sentence. Hidden layers perform transformations, breaking down patterns into meaningful information. And finally, the output layer provides the AI's decisions, such as classifying an image as a cat or a dog. Neurons in each layer communicate using activation functions, which decides whether information should pass forward. Additionally, weights and biases determine how strong neurons influence one another. Helping refine predictions over time, these components work together, allowing AI to learn and make intelligent decisions. Now, how neural networks learn. Neural networks improve through a process similar to how we refine skills. At the heart of this process is backpropagation, which allows the AI to analyze errors and adjust accordingly. This works by calculating a loss function, which means how far off the AI's prediction was from the correct answer. Then, gradient descent helps the network tweak its settings, reducing errors in the future predictions, and over time this cycle repeats, allowing AI to refine its accuracy. This process powers applications like self-driving cars, which continuously learn from the road conditions and driver behavior to improve performance. Applications of neural networks. Neural networks are transforming industries in powerful ways. In healthcare, AI assists doctors by detecting diseases like cancer and medical scans. In entertainment, platforms like Netflix and Spotify use AI to personalize recommendations based on viewing and listening habits. In automotive technology, Tesla and other self-driving cars rely on neural networks to interpret traffic conditions and make real-time driving decisions. The ability of AI to analyze vast amounts of data and make intelligent predictions is making our daily experience smarter and more efficient. Next slide, we're going to be talking about introduction to reinforcement learning, or RL. Reinforcement learning, or RL, is a method where AI learns by interacting with an environment and receiving rewards or penalties for its actions. Think of it like training a dog. When it follows a command correctly, it gets a treat. Similarly to AI agents take action, receive feedback, and adjust their behavior to maximize rewards. This makes RL especially useful for robotics, gaming play AI, and financial modeling, where AI must learn strategies without explicit programming. The ability to learn through trial and error allows AI to adapt to dynamic and unpredictable environments. Ready. Next one, we'll go into AlphaGo, AI and strategy games. One of the most remarkable examples of RL learning is AlphaGo, an AI developed by DeepMind that defeated world champions in complex board game Go. AlphaGo was not programmed with specific rules. Instead, it was played millions of games against itself, consistently refining its strategies. It used a technique called the Monte Carlo Tree Search, or MCTS, to evaluate the best possible moves. The AI's ability to discover new strategies never seen before in human play showed how reinforcement learning could surpass human intelligence in strategic decision making. This breakthrough paved the way for AI applications in fields like finance, logistics, and scientific research. Now, reinforcement learning from human feedback, RLHF. While reinforcement learning is powerful, it sometimes develops unwanted behaviors. To prevent AI from making biased or harmful decisions, RL reinforcement learning from human feedback, or RLHF, allows human trainers to guide the AI's learning process instead of purely relying on reward signals. AI receives feedback from real users who rate responses based on usefulness and safety. This technique is essentially for AI applications in content moderation, customer service bots, and healthcare diagnostics, ensuring AI makes ethical and reliable decisions. By integrating human oversight, we create AI that is not only intelligent but also aligned with human values. How does ChatGPT use RLHF? ChatGPT is a prime example of RLHF in action. Initially, it is trained on vast amounts of text from books, websites, and conversations. However, without guidance, it might generate incorrect or biased responses. To refine its output, human review rate AI generated responses, allowing the model to adjust and improve. This fine-tuning process helps ChatGPT provide more accurate, relevant, and safer responses. Thanks to RLHF, AI chatbots can engage in meaningful, context-aware conversations, making them useful for customer service, education, and even creative writing. AI and machine learning tutorials. For those interested in learning how to build AI models, Code Inforium is excellent resource. It offers practical coding tutorials on topics like neural networks, reinforcement learning, and AI-powered applications. Whether you're a beginner or advanced programmer, these tutorials provide hands-on experience helping you understand logic behind machine and learning algorithms and their real-world application. Another great source to learn more is computer graphic learning. AI isn't just text and numbers. It also plays a big role in computer graphics and digital art. The Graphics in 5 Minutes channel breaks down how AI enhances 3D modeling, visual effects, and gaming graphics. Topics include ray tracing, which creates realistic lighting and shadows, and procedural generation, where AI helps design realistic environments in the video games, and AI advances will continue to revolutionize how movies, games, and virtual worlds are created.